Section C, the simple pendulum.
The simple pendulum. Some use the pendulum as a convenient hypnotic device.
Follow the smooth motion of the pendulum. You will give me a passing grade on my physics test. You will give me a passing grade on my physics test.
Some people just use it to set up physics problems. Either way, the simple pendulum consists of a mass that swings on a cord of negligible mass. That means that we can ignore the cord's mass for our purposes. If the angle of the swing is not too large, then the period of the pendulum is 2 times pi times the square root of the length of the pendulum divided by the acceleration due to gravity. Let's see that equation in action and do an example.
Let's say you've timed the period of a pendulum and found it to be 4.6 seconds, and you want to know how long the cord of the pendulum is. Well, you could either measure the cord, or you could use our fancy new equation. So let's do it.
Well, we have the period, so to find length, all we've got to do is plug in our values in the equation. Period equals 2 times pi times the square root of length over the acceleration due to gravity. Then we'll get our answer.
That's t equals 2 pi times the square root of L divided by g. To isolate length, square both sides and we get t squared equals 4 pi squared times L over g. Solving for L equals gt squared over 4 pi squared. Filling in the acceleration due to gravity, 9.8 meters per second squared, and the period, 4.6 seconds, we get L equals 9.8 meters per second squared times 4.6 seconds squared divided by 4 pi squared. After all that, we find that the length of the pendulum is 5.3 meters.
Wow, that's one long pendulum. I wouldn't want to even be in the same town as that thing. I think it's time to review.
Simple harmonic motion is the basic vibratory motion an object undergoes when it is subjected to a restoring force that's directly proportional to its displacement from equilibrium. This type of force obeys Hooke's law, F equals negative kx, where k is the constant of proportionality particular to every object undergoing simple harmonic motion. The maximum potential energy of the system equals the system's maximum kinetic energy, or 1/2 mv squared equals 1/2 kx squared.
The period t of an object undergoing simple harmonic motion is the time it takes to complete one cycle. Frequency, f, is the inverse of period and is measured in hertz, and the amplitude is its maximum displacement. For an object oscillating on the end of its spring, its period, t, equals 2 pi times the square root of mass over k, and the period of a simple pendulum equals 2 pi times the square root of length divided by g.